السلام عليكم ورحمة الله وبركاته. حياكم الله جميعًا. معكم نورة الرجيبة، أنا مساعدة الوكيلة للدراسات العليا والبحث العلمي. أرحب فيكم جميعًا في هذه السلسلة من لقاءات البحث العلمي اللي نقوم بتنظيمها دوريًا. في هذا الفصل الحمد لله نظمنا عدد من اللقاءات في مواضيع مختلفة في البحث العلمي. في اللقاء الخامس لهذا الفصل اللي نسعد فيه باستضافة دكتورة بشرى الأحمدي من قسم تقنية المعلومات، اللي راح تكلمنا اليوم إن شاء الله عن تطبيقات الذكاء الاصطناعي في الأمن السيبراني. دكتورة بشرى نبذة بسيطة بس عنها، هي أستاذ مساعد بقسم تقنية المعلومات جامعة الملك سعود، وباحث زائر في جامعة أكسفورد، حيث حصلت على درجة الدكتوراه في الأمن السيبراني. كذلك دكتورة بشرى هي مستشارة في الأمن السيبراني، وهي كذلك مصنفة كخبير تطوير في تعلم الآلة من جوجل. عملت سابقًا في كل من سيسكو وأبل في الولايات المتحدة الأمريكية. ومن الناحية البحثية دكتورة بشرى مهتمة في أمن الشبكات واكتشاف البرامج الضارة الmalware detection and كمان تطبيقات التعلم الآلي في الأمن السيبراني. ما أبغى أطول عليكم، تفضلي دكتورة بشرى.
شكرا لك دكتورة نورة. بسم الله. شكرا جميعا للحضور، وشكرا دكتورة نورة على الاستضافة. اليوم إن شاء الله I will talk about اللي هو application of AI in the cybersecurity field. Both AI with cybersecurity are really big fields. Okay, there is, though, however, definitely a lot of intersection between them. There's a lot of intersection between the field of AI and cybersecurity. And what my research really looks at, it looks at this intersection, specifically how we can apply artificial intelligence or machine learning to solve cybersecurity challenges. Inshallah, in this talk, I will give you some of the examples of applications of AI in cybersecurity. And then we're going to dig deeper and dive into specifically the use of AI or machine learning for detecting malware. The AI domain itself is large. The AI itself, you can have computer vision, there's NLP or natural language processing, you have voice recognition, and also AI encompasses اللي هو machine learning, whether it's supervised machine learning, unsupervised machine learning, you have also reinforcement learning, deep learning, etc. And there are many research on developing these algorithms. For example, Dr. Noura last time, she talked on the specifically about natural language processing and the research directions in that domain. So all of these algorithms will, and the models that you can create from them serve as a tool that you can use and apply in the cybersecurity domain. So anything that you can, any of the AI domains, you can use that as a tool for in the security domain. For example, you can use natural language processing and then apply or use the social media data or data from the dark web. And then you can use that to detect, for example, cybercrime. So if you can use NLP to analyze text, analyze tweets or any form of text so that you can detect abuse, such as child bullying. So that's one of the examples. You can also, for example, use machine learning algorithms, مثلا random forest, support vector machine, and then in that you plug in network traffic data. And then with that, you will have applications for intrusion detection or user profiling. Similar in mobile phones, if you use machine learning and analyze apps behavior, how your apps on your phone behave, you can use that to determine if an application you downloaded is a good application, or is it a malware, or is it stealing your data. Similar for voice recognition. You can use voice recognition to, for example, it's actually used currently in attacks, and you can inject commands in voices using machine learning. You can use image recognition, and then you can analyze malware behavior and represent that malware behavior as an image. And together you can use that for malware detection. Also machine learning and human biometric data. If you combine them together, you also have biometric authentication. So basically any cybersecurity application where you want in that application to find an attacker, find an intrusion, an adversary, or you want to build a defense system or even an authentication system, and you have some form of large data or large quantities of data, then in that application you can use AI. And there are many research out there that use AI or machine learning to solve cybersecurity challenges, such as for malware detection or intrusion detection, whether you're analyzing data from the host, the computer, the server, or you have network traffic. You can use machine learning to detect cybercrime, whether it's on the social network or any form of data that represents crime. You can analyze that using machine learning and detect the cyber criminals. You can use that for biometrics or authentication, for example, fingerprints, iris scans, pulse response. There are a lot of biometric research out there that the fundamental tool they use is machine learning. Also, Internet of Things security generates a lot of data. You can use that data and use machine learning to detect attacks. Security operations centers. These are the people in an organization that monitor everything that the organization does in terms of users logging in, network traffic. All the different kind of data are monitored in the SOC. So you can use machine learning to help them automate some of their tasks and make their lives easier. Also in vehicle safety or security, self-driving cars, that in itself, they use a lot of machine learning for example, image recognition, voice sensors, and all sorts of machine learning algorithms are applied. But then you can use machine learning to make sure that you want to protect the people in the car. You want to make sure that the machine learning algorithm does not go faulty or is attacked so that you can, it can lead to accidents. So there are many ways and domains that you can apply machine learning to cybersecurity. And any application where we fear an adversary, for example, we fear someone who might use that technology to steal data or cause a financial damage or even risk human life, such as in securing driverless cars. We can use machine learning to build detection models, detection systems, authentication system, prevention systems. And so a lot of the cybersecurity research now are looking at how they can incorporate AI in solving cybersecurity solutions. So let's talk about one of these problems in that domain. And actually, this is one of my research areas that I'm looking at, is how we can detect malware using machine learning. So malware detection itself has been around for a while now. So we started early on with signature-based detection systems, and we've now moved to more machine learning-based systems for malware detection and to enhance the detection of malware. So usually in anti-malware signature-based systems, this is actually the most commonly used way to identify and take action against malware today. Most companies actually use signature-based systems. So here you already know, in a signature-based, you already know what the malware looks like. You know how it looks, and you have seen it before. So it's a malware that you've seen before. So you can write some kind of signature that represents that threat and can detect that threat. Examples for it is the traditional antivirus systems, which are signature-based and that are used in a lot of companies. The other one is heuristics-based approaches, where signature-based systems can only detect attacks for which a signature has previously been created. So you know what the malware looks like. However, you can also detect malware through some kind of classification based on heuristics or rules rather than patterns or signatures. And here you try to attempt to detect any type of misuse that falls out of a normal system operation. So you know that a normal network traffic looks like this. Anything that goes beyond this normal traffic is considered an intrusion, a malware, which is similar to, for example, anomaly detection systems. The other one is also that a lot of research is moving towards is machine learning based. So machine learning based is actually robust if it's done properly. And if it's done properly, it can actually detect unknown threats. And that's one of the main reasons why we now use machine learning, is because we want to build systems that are able to detect threats that we don't know about. So if you look at signature-based, it's very good in recognizing known threats, something that we already know, but we cannot use it to detect unknown threats, something we don't know. In addition to a lot of the problems that we have with signature, for example, it's very slow to deploy signatures in all of the network devices. There's a lot of issues of benign triggers, which is one of the main problems that malware detection have, is that they detect something that looks like a malware, and they detect it correctly, but for that specific organization, it's not a malware, it's something else. So that's a lot of the issues of signature-based, but still used a lot today because we want to use them to detect threats that we know. Heuristics, they recognize known indicators, but they rely on these indicators to detect. And they have a lot of false positives. So they tell you that there is a malware when it's not. And that's one of the main issues in heuristics. Machine learning based, they are robust. They can help in detecting unknown threat, but one of the main disadvantages is that we really need a lot of data for it to work. So although some of these issues you might think of as industry issues, when we as researchers should really care about the research side, that's true. However, when we do conduct system research in general, so when we're trying to propose a new system or a new method, we really need to consider how they're used in the real world. How is your system going to be used in the real world to detect malware? And when we do the research, we need to convince the research community that this system can be used in real world settings. And I'll talk a little bit more about this at the end when you think about evaluating, because that's a lot of the issues that I see with papers that are being submitted to conferences. They invent a very good approach to detect malware, but when you think about it, you can't really use that system in real world. So a lot of the papers get rejected just because of this, and we really need to consider how such systems are used in the real world. So let's talk a little bit about machine learning. So in a machine learning application, you usually have a similar pipeline to the one on the right. So you collect the data that you need. It can be, for example, labeled data. This data can be network traffic, for example. And then you need to engineer features from this data. So you need to determine what features in the data can be used and which provide meaningful distinctions. You then can use machine learning algorithms. So you can use random forest, support vector machine, deep learning. You have to choose which algorithm you want to use and to build the model, which then you will evaluate and test with new data that you get. And how you evaluate it, we'll talk also about it in this talk. But really what makes it unique, you probably use actually the same pipeline and the same structure in any machine learning application. So whether it's for cybersecurity or not. But what really makes it unique is the first one is the feature engineering. And the second one is what machine algorithm are you going to use? And these are what a lot of the research in the research community differ on. Basically, in any paper, the things that will be different is how they engineer the feature and the machine learning model that they use. So when you evaluate and when you read papers for example, malware detection or any application of machine learning in any domain, focus on these two. These are the main things that make this system probably unique. So when we do look at the malware research, we actually first look at what's the objective. Are we trying to detect the malware? Are we trying to say which malware family it is? Is it, for example, TrickBot? Is it WannaCry? What's the malware family? We might want to say, okay, is this a Trojan? Is this a ransomware? So that's some kind of family classification. Or are we trying to analyze the malware? Are we trying to figure out what it does and how it behaves? So based on this objective, we can determine which machine learning algorithm we want to use. Do you want to use supervised machine learning, unsupervised, semi-supervised? And a lot of these decisions are based on the data. Do you have labeled data or not? And if you don't have labeled data, you probably would can only use unsupervised learning. So we determined what's the objective of the system, what machine learning algorithm we want to use. We also need to talk about the feature engineering. How are we going to engineer the features? What is the features? Are we going to look at network traffic? Are we going to use the API or system calls on the host? Are we using opcode? Are we using byte sequence? And these features, we actually determine them based on how we extract them. So are we performing static analysis, dynamic analysis, hybrid analysis? So a lot of research use different combinations of these. So depending on what your objective is, you can choose which feature you want to look at. So the algorithm you use, as I said, really depend on the objective and the data also you have. For example, if you want to group the data into groups and you have unlabeled data, so you might use clustering. If you want to divide malware, for example, to is this network traffic malware or is it not malware, we might use a classification approach, a binary classification. We can also use multi-class classification when we want to, for example, determine if this malware is a Trojan or a worm or a ransomware. Because we have more than 2 classes, we will use multi-class classification. We might use regression, or if we want to derive some kind of patterns and rules, we might use rule extraction and so on. So basically, the data you have and what your objective determines what model you can use. And you as an AI and security researcher, you really need to follow the developments in 2 domains. You need to look at what AI research is talking about currently. Maybe AI researchers have came to new discoveries to make a model faster or to have higher accuracy that can help enhance the security systems. So the first part that research differ on is malware detection, is their objective, and the resulting machine learning algorithm they use. The other one that you really need to think about is the feature engineering. And I believe this is really what makes or breaks the research. What features are you using? And the art and creativity in machine learning is in the feature engineering. So what features are you using? Are you using, for example, the number of packets, the size of the packets, the protocol, if you're using network traffic, for example? Then if you decide what features you're going to use, how are you representing them? Are you using statistical analysis? Are you using behavioral representation? This part may be actually easier in other domains that are not security. For example, in text for NLP, you know what you're looking for. So language has been around for centuries. You know how a sentence looks like. It consists of words, and these words are constructed in a certain way, and so on. But the main challenge in security is that we don't know what a threat looks like. We don't know what a malware can do, how it behaves on the network. We don't know what data we consider to be malware and what does a threat look like. So this is one of the main issues in security and the application of AI in security, is that we don't know what a threat looks like. And that's why in security, and when we use AI in security, actually a lot of industry now has moved to this direction. But as a researcher, you really need to be knowledgeable about the domain that you're in. So if you are in using AI to detect malware, you really need to understand how malware works, so that you are able to engineer features and know what a malware looks like. So as a researcher in malware detection, you need to understand how a malware works. So spend time analyzing malware. Take courses on malware incident response, because the more you know about how malware works, the more you know what features in the malware behavior are unique and can be used to detect them and can be used to distinguish them from normal benign traffic. So some of the malware behavior that that researchers are looking at is behavioral features for malware. So behavioral features are features that are extracted and are engineered based on how the malware behaves rather than statistical features. So we want to really move away from statistical features, because research have found that a lot of malware actually are able to evade detection and able to change their behavior so that they can evade the detection of systems or that use statistical features. So we want to look more into behavioral features that look at how the malware behaves, which usually is a lot harder for the malware to change. So some of these behavioral features could be host-based, such as system or API calls. Some are network features. And there has been a lot of research on this area on behavioral detection of malware. But what makes one approach more better than the others in terms of detection? It's not always about if you have 99% accuracy or 98% accuracy. No, you really need to see how these features, what additional positives that these features are providing. For example, you might use features that are privacy preserving. That means you're taking network traffic that are encrypted, and that will also be that's also be used for preserving the privacy of your of the network users. You can also think about features that are generalizable. So these are features that can detect any type of malware, whether you have seen it or have not seen it before. And there's a lot of papers that look into this. I'm providing some examples on the right, but you can really take a look at these research and understand the kind of behavioral features that they are offering and what makes it unique than other papers. For example, as I said, feature engineering itself, it's an art. So you can really think of various ways you can represent the data. For example, you can represent the data as sequence of characters, so similar to text. Then you can use NLP methods such as n-grams to derive malware patterns and use that for the detection. You can represent the network communications as Markov chain model. And then when you present it as a Markov chain model, you can take the state transitions matrix and use that as the features. This is one of the research that I'm working on. Actually, it's published this year. You can take a look. That uses Markov chain models to represent network traffic. Also, you can represent the data as an image, and then use image recognition models to distinguish between whether this network traffic is a malware or not. So this is one of the papers that detects IoT malware using image recognition. So this is what, for example, this image represents what a malware looks like. And this image represents what normal traffic looks like. And then you can use that and then use image recognition model to determine to classify whether this image belongs to a malware or is not a malware. So as I said, feature engineering is a very creative process. You really need to think of how you're going to represent the data and which machine learning algorithm that you're going to use. Another way to code, for example, network traffic that I have explored with during my research is representing the network as a sequence of connection state. So let's say we have this sequence of network traffic. So this is flow 1, 2, 3, 4, and 5. And we use something called Zeek. Zeek is a security monitoring tool that you can give your data, and it will give you a lot of various behavioral features about the network traffic. I really recommend, if you're into network security, to take a look at Zeek and the various features that it can provide. For example, these are some of the features. So it can tell you the connection state. Was this connection accepted by the receiver? Was it rejected? Was there no replay, and so on? And it gives you these different 13 different states. So if we use that and we just represent each flow as based on the connection state. For example, the first one might be a normal connection. So we can code it and give it an SF, which is a normal establishment and termination. Maybe the second one was rejected. So the receiver didn't want to start this communication. The third one was rejected. The fourth one was rejected, but the final one was accepted. So let's say we code this. We represent each flow with some kind of coding based on the connection state. So if we do that for all our network traffic, we'll get something like this. So we have a sequence of characters. And these different sequence of characters represent the connection state for that network traffic. And if you look here, you'll see that there is a sequence of rejected connections. And that's actually some of the malware behavior, is that when it sends a lot of traffic that was rejected, that means it's trying to scan the network. So this is some kind of pattern that we were visibly be able to detect and see, okay, this actually looks like it might be malware. So we can represent network traffic as a sequence of characters, and code it that way. And there's been a lot of papers that take this approach. But what does this representation really remind me of? Well, it's similar to text sequencing, correct? Or it might look like DNA sequencing. So we can actually use algorithms that have been found very highly accurate for solving text sequence analysis or DNA sequence to solve the malware network detection. So we can map the network flow sequence problem to a problem that we known and have studied for a long time, such as DNA sequencing. And the idea is to map the new machine learning problem, the network malware detection problem, to a problem that you have is previously well-established machine learning model problem, such as text sequence or DNA sequence. So since this is a sequence now, we represented the data, we changed the data, we engineered features so that we can have a sequence. Now, maybe this we can use, for example, deep learning. Deep learning has been found to be very good in analyzing sequences and so on. So you really have to think about the various transformations that you can do to the data, and then you can think about what's the best model that can be used for that data representation. And as I said, there's a lot of research that takes a look into this. The recent one probably is the paper that I published in 2018. But then you can also take a look at how we can represent the data as a Markov chain model, which was out this year. So when thinking really of applying machine learning to cybersecurity, really think about what your features are and how would you engineer them, because this is really what makes the paper. So what are some of the challenges in AI and security? There are many challenges that we need to consider when we research machine learning and cybersecurity. And if you look at problems in other well-established domains, for example, in image classification, or any other domain, we suffer from the same problems. But also cybersecurity suffer from some more inherent problems even more. So in addition to problems that any normal AI domain has, cybersecurity also really suffers in the data, the feature engineering, and most importantly, that we're facing an adversary, a moving target, or an unknown that we need to anticipate and prepare for. So let's talk a little bit about these challenges. The most important thing when we build machine learning model is the data. Do you have enough high quality and quantity data? And many times getting the data you need is a challenge. And I really, really urge you, before you think about using AI in any of the cybersecurity domain, really think about, do you have the data? Can you find the data? Because if you decide to go through this route and you don't have access to the data, you won't be able to do your research. So think about that really in the early stages of your research or in your studies. Can I get the data? And there are various ways you can get the data I'll talk about in the end of this presentation. But when you think about taking data from, for example, an industry collaborator, or for example, the university decide that it can give you data, they might be reluctant to share the data or anonymize it to the point it becomes unuseful. So take a look at the data. Is it high quality? Can you actually use it? Or it's changed so much that it becomes unuseful. The other one is that the problem is that we have a lack of labeled samples and certainty in ground truth. You might have some traffic. The university said, okay, you can take some network traffic, but you don't know which one of these traffic is malware or not. So that's a problem. It has to be labeled for you to use supervised machine learning. It can be not enough data or low quality data or missing data, meaning you get some parts of the data that also will make the data not useful. So that's one of the main challenges in this domain. You really need to have high quality data. So think about this before you go through this route. As I said, the other one is feature engineering. You really need the expertise to engineer good features. You need to understand the domain. And to build that, it really takes a lot of time. So if you think about the research part, the feature engineering is probably the most that will take a lot of your research time, is what does the malware look like, or what does the threat look like? Another challenge is that adversaries change behavior. They're considered moving target. A malware today is not the same malware tomorrow. You're always facing an adversary. You have someone that changes the malware. You have a human brain that can determine how they can change the malware so it is not detectable. So that's one of the things when you think about in features. How good are your features in detecting something, the same malware next year or the year after? You have to make sure that your features are generalizable, that they don't just focus on specific behaviors of a specific malware family. So the big challenge in security particularly is that the adversaries change their tactics. They are moving targets. And to be able to detect threats using machine learning, you really need to know what they look like. So think about that when you engineer the features. Make sure that you use features that can be applied to any type of malware and not one malware specifically. And then you have challenges in AI itself. So you have adversarial machine learning. You have, it's a technique that is employed in machine learning to fool the model. So you're trying to poison the model. And that, for example, if you look at email spam, if we hire a lot of bots from a botnet and let them click on a spam and label it as not spam, that's a type of adversarial machine learning. We're trying to trick the model to think that this behavior or this email is not spam. So that's one of the challenges in AI that you take into consideration. The other one is weaponized AI. We have a lot now of attackers actually using AI to attack, which is a bit scary. So they use machine learning, for example, to understand how a user uses their machine, and then they mimic a user's behavior so that they are not detectable. They're using machine learning, for example, to generate this, which is deep fakes. That is something I'm particularly interested in because it's an issue if anyone can take any picture of you and put it in a video, any video. That's actually a main threat that we all need to, as researchers, think about how we can detect such activities. And the third one is that it's a moving target, as I said. Malware change their behavior. Every time you think that you can build a model that can detect malware, that malware changes and then you have to redo it again. So that's the main challenges in AI security specifically that also is opportunity for research. So let me just give some tips on research. For example, when looking at ML in security, think about what's your threat model. What are you detecting? Are you detecting all types of malware? Are you focusing on ransomware? You have to state clearly what your threat model is and set your assumptions from the malware that you detect have this certain behavior. That's why it's detected clearly so that you can motivate your approach and set the threat model clearly. Generalizability, this is one of the main things that makes papers rejected. They say, okay, model, it can detect malware. How long can this model last before it requires training?
دكتورة بشرى، ما أدري إذا تسمعيني بس ما عاد نسمعك. حياك الله، أهلا دكتورة.
الله يحييكم. متى انقطع؟ هنا؟
إيه تقريبا.
اوكي الحين نكمل. شكرا لك.
يعطيك العافية.
Okay, so you have to think about how long is your model valid because before it requires training. Because if you have to retrain it every time, that's very costly. So think about that, and also, can your model detect new malware? So machine learning detectors, they really need to maintain their performance over time. So you have to ensure that your detection capability is able to detect new malware we haven't seen. So think about that when you propose a new system. Is your system be able to detect new malware and provide research and experiments on this? Is your approach content agnostic, or is it privacy preserving? If a malware encrypts the traffic, will it still, your system will be able to detect malware or not? Think about encryption, think about privacy as well when you when you develop your system. When you think about the machine learning models design, think about class imbalance, overfitting. What metrics are you going to use? What's most important, false positives or false negatives, or both? Are you going to use cross-validation? Are you going to use stratified cross-validation? Are you going to use a separate test set? How are you going to hypertune your parameters as well. So all of these, you think about it and you actually state it in the research paper of how you designed your machine learning model. Also look at what are the important features. What features in your data are actually the most important, and have and do some experiments on them. Spend a lot of time, in addition to understanding your data, spend some time to understand your features. Another thing, if you're interested in detection, there was a paper that was out in 2019. It talked about temporal training consistency. That means that all samples in the training set are temporally precedent to samples of the testing set. So when you train the model with samples for malware in 2018, you train the model to detect malware in 2019. So you don't train a model using data from 2019 to detect malware in 2018. Malware changes. Malware becomes more sophisticated. So I really encourage you to read this paper if you're interested in any kind of security AI applications. Think about how you're going to evaluate. How would an adversary evade detection? What happens when this happens or X happens? Really think about, if you have this system, how would your malware evade the detection? Think about that when designing experiment. Also take a look at this paper, which is Outside the Closed World on Using Machine Learning for Network Intrusion Detection. This is a very important paper that you really need to read and understand before you even dive into using machine learning model for intrusions. And always think, high accuracy alone is not enough. Writing a paper and saying, oh, we have a 99% accuracy would not make this paper publishable. You really need to think, what does your approach differ based offer in the features? Is it privacy preserving? Can it detect new malware, and so on? And if you take a look at the paper we published this year, you can also take a look about how we set our approach from other previous research. So we don't focus and say, oh, our paper is better because we have 99% accuracy. No. You have to, for example, think about encryption, its ability to detect unknown malware, what things or features in detection that makes it better than other previous research and improves on them. So take a look and compare your approach to existing research other than just looking at the accuracy. Future trends in AI and security, I'll go through this quickly. So we found that the main thing that we really need to improve on is security operations centers and using machine learning for security operations centers. And we actually did a study to investigate this further to determine how we can improve machine learning in security. And this is a research that I'm leading with the University of Oxford, with some researchers at the University of Oxford. And we found that to improve machine learning, we need to use these various new emerging ideas, how we can use transfer learning. Explainable AI is a big topic now, and cognitive security as well is a big topic. So we're looking into this and how we can improve security operations centers specifically. And if you're interested to learn more about this project, we recently got a big funding. Just reach out to me and can tell you more. Just a bit of quick tips and resources for researchers. Make sure you follow these top 4 conferences in security. These are the main 4. So take a look at these. As I said, make sure that you have good quality data before committing to a machine learning idea. Think if you can collaborate with industry. A lot of companies now are in the kingdom are willing to participate in research. So try to find these collaborators to get good quality data. Know the main research groups. So if you're interested in malware detection, who are the main research groups around the world that do this research, and follow their publications. Always try and open source your systems and data set. That's actually a plus when you publish, that you open source your approach and data set. And a lot of conferences now take that into consideration when evaluating research. Attend talks and seminars in other domains for inspiration. I mean, when I started, I used to go to a lot of talks that are not in my area, bioinformatics, natural language processing. And what I found is it's the same problem, it's just different data. So as I said, DNA sequencing looks like malware sequencing. So that's where I came, I had my inspiration. So do attend talks and seminars in other domains. Don't be discouraged with trendy research. When I started, a lot of people told me that malware detection is a dead end. We've done all we can. And over my research, I found that, yes, a lot of research exists, but why not companies are still not able to detect malware? So I actually went to these companies, I did a qualitative studies, and I knew exactly what was missing. So that started a new research direction in using machine learning for automation in SOCs and how we can improve on that based on my qualitative study. So don't be really discouraged. A lot of research resources, I will share this as well. There's a lot of that's offered by Google for researchers in terms of credits, in terms of tools that can help you understand your data, like What If, TensorBoard. Colab is a very good tool that I used a lot. It's like a Jupyter notebook hosted at Google, and you can use Google's TPUs to do machine learning on that. TensorFlow Research Cloud has also services. VirusTotal, which is the engine where you can get malware traffic or malware samples, you can actually email them. There is a support for researchers and get access to data. I mean, this is a very big, good minefield. If you're interested in malware detection, just contact them, explain your research, and they can give you free access to VirusTotal. Datasets, there's a lot. As I said, look at industry collaborations, see if there's someone in KSU that can help. GitHub also has an education pack that allows you a lot of free resources for researchers. There's a lot of access to cloud computing and resources. Also take a look at this. And really, if you need something, email and ask. Ask whatever company that you want, whether it's VirusTotal, Google, ask them for the resources, because mostly they will be very cooperative and will give you some kind of free access. With that, thank you very much. I hope we have time for questions. I'm sorry if I went a little bit overboard, but thank you very much.
يعطيك العافية دكتورة بشرى، صراحة أثريتينا كثير أحس أنها خلاصة ما شاء الله خبرتك وتجربتك في التقاطع ما بين الذكاء الاصطناعي والأمن السيبراني، بشكل غطيتي التوبكس بشكل جدا ممتع وشامل. يعطيك ألف عافية. المايكس مفتوحة، فإذا في أحد عنده أي سؤال عادي يعني تفضلوا خذوا راحتكم. كمان لو حابين تستخدمون الشات to ask questions you can use them. يعني نقدر نستفيد من 10 دقائق الباقية للأسئلة في حال عندكم أي سؤال. إذا ما في أسئلة أنا عندي سؤال يعني، بس إني كنت بستنى إذا في أحد عنده أسئلة من الحضور. أوكي طيب دكتورة بشرى، أنا عندي سؤال يعني سؤال فضولي يمكن أكثر من أفكر مثلا الحين في استخدام التطبيقات السايبر سيكيورتي اللي تستخدم الماشين ليرنينج. Thinking about deploying such systems أو such models. هل من خبرتك يعني do you see that there is more challenges in deploying such systems بالمقارنة مع other systems? If you can talk a little bit يعني about using such models to detect malware مثلا أو بشكل dynamic يعني as we go, and if there is any challenges in deployment.
That's actually a good question. So some of this, I actually, as a researcher, you usually are in your kind of bubble. You have your data, you build the model, and you have the model. and then you kind of, you have data that you test, you get your accuracies, you get your results, and that's it. But yes, in real world, there is a lot of, when you really deploy it, it's another issue. I mean, I remember when I worked at Apple, I came from research and went to dive into billions of data. And I had to kind of think about scalability. How would this model, how you build the pipeline in terms of that. There's actually good talks on this. And I know TensorFlow, for example, they have a pipeline that can help you scale in real world. There is also a lot of Apache's products can help you to stream the data for real-time detection and so on. But this is, in fact, a lot of the focus is how you can build the model. And then we kind of stop there and we don't think how scalable it is. And when you go to industry and when you think about that, it's a totally different issue because of the size of the data. So yes, there is a lot of, if you take Apache streaming, Storm, it's a various different building blocks. And that's where the security architect comes in and helps you scale that data and be able to offer detection. You might also build models and have redundant models based on your application. But yes, there is actually a good presentation on this using TensorFlow that I can share that helps and shows how you can put that model into production. For example, how you can put it into Google Cloud and use that and be more scalable.
شكرا. أتوقع نقدر نضيفه حتى في اللينك في الديسكريبشن لما نرفع الفيديو إن شاء الله. في أحد عنده أي سؤال؟ يعطيك العافية طبعا دكتورة.
شكرا لك.
Okay, so we have a question from the chat. Is cryptanalysis a good topic to search about and combine it with ML? Sumaya.
Crypto?
I think cryptanalysis.
So as in crypto mining kind of? Like cryptocurrencies or?
I don't know what she actually means. Sumaya, إذا تقدرين توضحين, that would be great. Okay, so cryptanalysis and brute force attacks.
So it depends on what your data is. So if there is data, and for data there is some kind of patterns that you can derive, then you can use machine learning and AI into it. I'm not aware about the latest research, but what I always do is I take a look at these 4 main research conferences that I mentioned: Usenext, CCS, IEEE, S&P, and see what is the latest in that area. And then I read more about it, and then you can determine, you can actually see, if you read the future work, it also gives you a little bit indication about where this research area is heading. And based on that, you can make your decision. You can say, okay, if I have that data and I can change the features this way, I might be able to detect and I might be able to improve on this paper that was published in a leading conference. So you can take a look at that. In regards to the area itself, I'm not an expert in this, so I can't tell you if it's going somewhere or not.
يعطيك العافية دكتورة. في عندنا كمان سؤال. I have a question. طبعا she thanks Dr. Bushra and Dr. Noura. I have a question. As Dr. Bushra said, malware are changing. Is it look like virus in biology? Is there any similarities ما بين I think اللي هي المالوير والviruses?
So yes, they change, and they change based on, because you have a human. The people who write the malware are very highly skilled. So if they see that there is a new detection system algorithm that detects malware based on this, they can change it so that that detection system does not detect the malware. So that's why in feature engineering, when you think about it, you want to make it highly costly for the attacker to change their malware. So you want to make it harder for them to change it. So you take into consideration or look at features that cannot be easily changed by the attacker. I'll give you an example. So a malware that sends spam, it has to send spam. Otherwise, it's not going to be a malware that sends spam. It will completely change its behavior. So if you can look at features that determine, looks at the behavior on the malware and extract features that look at the spam, is he sending spam or not? Then the malware author needs to change the malware completely, or the objective of the malware, to evade detection. So here you increase the cost on the malware author to change their malware. They require more coding, they need to find new ways, and so on. So you made it harder for them to change it. That is the research that that's actually being more accepted nowadays, is that you just don't present a detection model. Give me a detection model that uses features that makes it very difficult for the malware author to change, like a virus in real world. So you consider how you can make it costly for the malware author to change their malware.
جميل جدا. في عندنا كمان سؤال. What about credit card payment fraud?
They do use a lot of machine learning for fraud. It's one of the main applications for fraud. They actually they use, I think, also Markov chain models for detection of fraud. The one thing actually I forgot to mention as well is that there are some applications that you don't need machine learning. You can use statistical models or like away from machine learning, or there's simpler ways to deal with it. If you can use that, that's even better. Don't just say you want to use machine learning model because it's the top thing right now. No, based on what the problem is for your research, if you can do it in something that's not machine learning, that's great. Like a lot of fraud, they just use Markov chain and they give them great results. But you can say, okay, this doesn't work, for example, in certain applications where you need machine learning, then yes, you can take the machine learning route. But if you can do something simpler, I think that's better.
Great. أنا أشوف إنه حالياً ما عاد عندنا أي سؤال إلا سؤال واحد بالنسبة أوكي. في عندنا سؤال الآن. Is it more secure to use machine learning? I think here referring to your last point.
No, machine learning لها other problems في الماشين learning. ممكن اللي هو يسمونها adversarial machine learning. هذه research domain لحاله اسمه adversarial machine learning. اللي هو كيف ممكن الاتاكر attacks the machine learning model. يعني ممكن الاتاكر finds ways to inject false data and then it can ruin your model. And this is very problematic, not only for security in any domain, uses machine learning. So adversarial machine learning is one of them that makes machine learning not probably the secure way to use. But it depends also on the application. As I said, if you design the machine learning model correctly, then you reduce the risk.
Great. يعطيك العافية دكتورة بشرى. شاكرة جدا وممتنة لحضورك وقبولك الدعوة والمحاضرة الرائعة هذه، وأتمنى أن الجميع استفادوا. في جانا سؤال على الريكوردد فيديو. الفيديوز كلها إن شاء الله راح تنرفع في اليوتيوب شانل حقة الكلية، وراح يعلن عنها إن شاء الله في التويتر تبع حساب الكلية للطالبات. شكرا جزيلا دكتورة بشرى، يعطيك العافية.
شكرا لك دكتورة نورة. Thank you everyone for attending. Thank you very much for everyone who asked questions as well. Thank you all.
يعطيك العافية، نلقاك على خير إن شاء الله.
إن شاء الله بإذن الله. شكرا لكم جميعا.